Welcome to using the chain rule. So recall from the previous video that if we wish to take the derivative of composition of g of f of x, what we should do is we should take the derivative of g and plug in f of x, and then we should multiply it by the derivative of f. So again, we take the derivative of the outside function, plug in the inside function, and then multiply it by the derivative of the inside function. So let's go ahead and find the derivative of f of x equals 5 times sine of 3x minus 2. So we want to view this as an outside and inside function. So 3x minus 2 is acting like my inside function, and 5 sine of blah will be my outside. So when we do this, what's going to happen? So we want to take this derivative. So the first thing we're going to do is find the derivative of 5 sine of u, let's say. So let's find the derivative of 5 sine of u. So we're setting our inside to be u. And then we'll multiply that by the derivative of u with respect to x. That's essentially what we're going to be doing. So 5 sine of u goes to 5 cosine of u. Then we'll multiply by du dx. And now let's go ahead and put our u back inside. So our inside function was 3x minus 2. So this again is our f prime of x. Is this. So we have f prime of x is equal to 5 cosine u times du dx, with u is equal to 3x minus 2. From here, we can go ahead and plug those back in. So we have f prime of x is equal to 5 times cosine of 3x minus 2. And now we need to take the derivative of 3x minus 2. And we get 5 times cosine of 3x minus 2 times the derivative of 3x minus 2 is simply 3. So we have the derivative is 15 cosine of 3x minus 2. Looking at our next one, let's go ahead and set our u to be that 2x to the 4th plus 5x squared. So if I want to take the derivative of g, I'm going to take the derivative of natural log with respect to u. And then I'm going to multiply by the derivative of u. At this point, the derivative of natural log is usually 1 over x, or in this case, 1 over u. And we are multiplying by du dx. From here, we can go ahead and plug back in our u's. So we have 1 over 2x to the 4th plus 5x squared. And then we are going to multiply by the derivative of u, so the derivative of 2x to the fourth plus 5x squared. At this point, if we take our derivative, we have, of course, to start off 1 over 2x to the fourth plus 5x squared. Then we will multiply by 2x to the fourth will go to 8x cubed, right? 2 times 4x cubed. 5x squared will go to 10x, right? 5 times 2x. And so we wind up with that our derivative is equal to 8x cubed plus 10x over 2x to the fourth plus 5x squared. So again, that is using the chain rule to find the derivative of the natural log of 2x to the fourth plus 5x squared. So from here, we're going to get into what your textbook calls the generalized power rule. So note, if we wish to take the derivative of the function f of x raised to the nth power, where n is an integer, the chain rule tells us that we would do the derivative of the outside function first. So we would do n times something to the n minus 1 with respect to the inside. So that would be with respect to f of x. And then we would multiply by f prime of x. So this is using the chain rule. It tells us this is the derivative if we have a function inside a power. Again, so far we have this for n an integer. So for example, if h of x is equal to 2x minus 1, the whole thing raised to the 7th power, I apologize, my screen is not scrolling. Now we're scrolling again. So we want to find the derivative of h of x equals 2x minus 1, the whole thing raised to the 7th power. If we had to use algebra to solve this, to manipulate it, we would have to multiply that out, raised to the 7th power. That does not sound fun. But if we use the generalized power rule, again, which is really just the chain rule, then we have what we need. So again, I'm just going to use u. So let's go ahead and set that inside to be our u. Then we have h prime of x. We would do the derivative with respect to u of u raised to the 7th power, and then times by du dx. Again, we know our power rule. We would just do 7 times u to the 6th power times du dx. At this point, plugging back in u, we have 7 times 2x minus 1 raised to the 6th power times the derivative of 2x minus 1 and then this becomes 7 times 2x minus 1 raised to the 6th power times the derivative of 2x minus 1 is just 2. And we wind up with 14 times 2x minus 1 raised to the 6th power. Again, technically, the generalized chain rule, we could jump straight to here. So with the generalized chain rule, we could jump straight to this rule. Well, sorry, the generalized power rule. Let's us start here. I find it convenient to just continue to work with use. As you get comfortable with the chain rule, you will likely no longer need to write use at all, and can just jump in, just like the generalized power rule lets us jump a little bit ahead. Again, as you get more and more comfortable with derivatives, you're going to be able to kind of pile a lot of steps all in one. You don't need to write out as many rows as I do. I'm just trying to show the thought process.